let's continue with geometric sequences. We're going to apply it to what you've been doing with exponential growth and decay. This is a nice little tie here. This is about as straightforward as you're going to get with the information in this section. Really what we're doing is we're going to take a sequence like 12, 6, 3, and 1.5 and then refashion it into a group of coordinates that you could put on the graph. So your setup of a smart chart from your past, and I don't know if you've heard that term before, smart chart. You guys that have been in my class in the past, you know that's what I call it. But we're going to set it up in terms of x. Instead of x and y, we're going to use n and then a sub n. Remember, a sub n is your nth term or leading you to that explicit equation or formula. So there's a nice tie between this example and then the next example in the video I'm going to present for you. We need to look at this as n being the first, representing that first term. Or think about this now. If n is 1, then a sub n would be a 1. Now, I'm not trying to confuse you here, but I want you to get used to how the notation works. That first term, obviously, is 12. So this represents our coordinate in a sub n. Also, it's very similar to x and y. That would give us a coordinate on our graph, 1, 12. So our second term there, that's 6. So to stay consistent, the second term, that's really 6. So that would be a coordinate 2, 6. And then our third term, or a sub 3, that's 3. That gives us the coordinate 3, 3. So you get the picture here. Now, if we plot these coordinates on the graph, we're going to start to see how a geometric sequence is related to either exponential growth or decay. The reason why now this is actually presented within this chapter, within this unit. So if our first term there is 12, we're just going to make a rough sketch here. I'm going to go, well, this is like 1, so 12 would be way up here. And then 2, and it's going to be, you can see your common ratio here is 1/2, so that's going to drop down to 6, halfway. And then your third one, it just keeps getting cut in half. And again, we start to see this exponential decay like what we've experienced previously in this chapter. Yeah, it's a nice connection. It leads us now into this next video I'm going to present for you. It leads us into a nice way of thinking to getting to our equation or the formula for that nth term. See you in the next video.